So you need to know stuff about transformations and you need to know stuff about sine and cos graphs. And then you're going to need to know stuff about other graphs. Okay, let's run through this really quickly. Sine graphs start where? They start at a median, right? And on the traditional graph, they start at 0, 0, right? So on the basic sine graph, they start at a median, and that is 0, 0 on your basic sine graph. The reason why that's important is we are going to transform graphs based off that original graph. So it's really important that you have an idea of where things are starting. Now, cos graphs start where? They start at a max, and that is at 0 and 1 on the basic graph. So here, they start at a median, and they head to a maximum. They start at a maximum, and the next point they head to a median. So on a sine graph, it starts at a median, but it's headed towards a max. Really important, because once we have reflections, you're going to need to know that it might still start at a median, but now it's headed to a minimum. Okay. Cosine graphs are a little more straightforward. Okay, so this is the layout of the transformed sinusoidal graphs. So A represents the amplitude. If A is negative, that means there's a reflection. B is used to find the period. It is not the period. It is not the period. Not the period, it's a helper. That's all that is. This is a helper. It's a helper number. C is the start point. It's also called the horizontal shift or phase shift, you might see. Those are the names that are sometimes given to it. Can you see that? Let me show the line. Okay. The median is going to be your vertical shift, your up, down. Okay, so here we go. We're going to do, so we did stretches, we did the increasing the amplitude, we squished graphs, we did all kinds of stuff in the A and B part of it. We've already done those. Today we're going to look at C and D, and then we are going to compile A, B, C, D. So we're going to start off with just our shifts. So nothing's really changed right away. Everything is still the same. This means we are shifting. Our start point used to be at 0, 0, and now it's shifting 30 degrees in which direction? Left. And our median so where was our median on a sine graph? Do you guys remember? We talked about that. Starts at 0, right? So this median is going to shift up to 3. That means all the graph is going to shift 3 units up. But I like to say our median. Okay, so this is how I like to graph things. You guys are going to find the most effective way for yourselves. But I like to run through my numbers. So I know that my amplitude is 1. Because there's nothing in front there, right? I know that my B is also 1. Because there's nothing in front here. Does that make sense to everybody? So I know that my amplitude is 1. The B value that's going to help me find the period is also 1. I know that the C value is negative 30 degrees. That's super important because that's going to be my increments. I'm not going to be working in radians. I'm going to be working in degrees. And D is my median. All right. Here we go. So now we got to put increments on this thing. Got to put increments on this thing. I'm going to use an erasable pen for a sec, and you guys can choose to do that as well. Okay, I don't think I have enough. 1, 2, 3, 4. Oh, I do. So 1, 2, 3, 4, -1, -2, -3, -4. I did my Y's first because I always forget to do those. I'm going to do some math first before I put my X increments on, and it has to do with the period. So to find the period, and I'm just going to move over here. To find period. Period is equal to 2 pi over b. Now in this case, are we in radians? No. So we're not going to use 2 pi, we're going to use 360 over b. So our b value we said was 1. And I know this seems redundant. You guys are like, it's obviously 360, but I'm going to write that. So the period is 360 degrees. All right. So I always do this before I do my increments. And then, this is like Scalion's math. I don't know where I picked this up, but I call them the something happening point. So in order to find the something happening point, we're going to take the period and we're going to divide it by 4. So 360 divided by 4, hopefully is 90 degrees. That helps me graph. I know that there is 4 parts to a period to return to where you are. So I know that every 90 degrees, something is happening. Is everybody okay with that? This may not make sense, but it will when we start graphing. This is helpful. You can do a table of values too if you prefer. If you prefer to do a table of values, you can do that as well. All right, where do sine graphs start? Sine graphs start at a median. So my first median is not going to be a 0, 0. It's now going to be at -30 degrees and 3. So my median did those transformations. So all values are going to subtract 30. All x values we're going to subtract 30. And all y values we're adding 3. Okay, this is where I'm going to use my erasable pen. I find this super helpful, and you guys might not like it. It has to be a dashed line if you use it. My pen's dying. Has to be a dashed line because it doesn't actually exist. I'm going to drop that median on there. My median, this tells me where my median is. So my median is at 3. What's my amplitude? 1. So from my median, I'm going to go up 1 or I'm going to go down 1. So I'm laying some boundaries on my graph that kind of help me remember that I can't go above or below these in the y. Well, that pen sucks. Okay. So they have to be dashed lines if you're going to use them because they don't really exist. They're just boundary lines for me. It helps me. You do not have to use them. I just find that they're super helpful. Okay. So my starting point is here. My starting point's here. Everybody okay with that? How big is my period? 360 degrees. Okay. Let's add some increments on there. -30, let's be +30, 60, 90, 120, 150, 180, 210, 470, 330, 390, and I can keep going. But that's how I'm doing that. I wanted the negative 30 on there just so we could see it. Pardon? Every, not big tick, every tick is 30 degrees. I just wasn't going to put in the 60 because it's going to cram it in too much for me. You can if you want to. So 30, 60, 90, 120, 150, 180, 210. Is that okay for everybody that I use those? All right, where did we say our graph now starts? The first median is at negative 30 and 3. Now again, you can use a table of values. There is no problem or shame in that. This is just a faster way to do it. Now I'm going to use my something happening point. Something happens every 90 degrees. It doesn't happen at 90 degrees. It happens after, like as you travel 90 degrees. So if my graph started at negative 30, where's my first point? Where's my next point, I guess is the question. What's negative 30 plus 90? Thank you. 60. So are we headed to a maximum? Are we headed to a minimum? Maximum. Okay, now we're going to add another 90 to it. So 60 plus 90 is 150. Where are we going now? To a median. That's why I find these lines helpful. You have to hit a line. You can't go from a max to a min. You have to hit the median. So at 150, we're at a median. And then I take 150, I add 90 to it. So 150 plus 90 is hopefully 240. And we are at a minimum. And 240 plus 90 is 330. And we are at a maximum now. If I go another 90. 330, so now I'm at 420, which would be here, which I didn't label. So remember, arrows have to go in the correct direction when I'm doing my wave. So when I hit, this didn't give me a boundary, like it didn't give me a restriction, so I'm going to put arrows on my graph saying that it's going to continue. So that's why that something happening point is super helpful, because it tells me where my next point is going to be. So if you remember the pattern of how sine graphs are graphed, you can just follow the pattern through. How does that feel? Not terrible, terrible? Do you want to do a table of values? Do you want to see it? Do a table of values? Yes, no? I'm okay not doing a table of values. Do you guys want to see it? Yeah? Okay. So let's grab this. Let's grab the sine table of values. Oh, where is that? So if we were to flip back to our very first page, I'm just going to do it right on this table, right next to it. So what were the two transformations that we had in our table? We had y equals sine x minus 30 degrees plus 30, right? That was the equation. It should be plus 30. Yep, you're right. So we're subtracting 30 from everything. So we're going to have to do a little bit of math in our head. So at negative 2 pi, which maybe we won't even go back that far. We'll just do the positive ones here. So at 0, 0, that point transforms to negative 30 degrees and 3. Because we're subtracting 30 degrees from our x values and we're adding 3 to our y values. So at 90 degrees, where am I? pi over 2 is 90 degrees. I got to subtract 30. Where am I? I'm at 60. We're going to do it in degrees just because that's what the other... So we're at 60 degrees, but yeah, pi over 3. We were at 1, so now we're going to be at 4. At pi, so at 180, we're going to be at 150, and we're going to be at 3. At 270, so that would be 240 now. And we were at -1, so we're going to be at 2. And then at 360, got a minus 30 from that, so that's 330. And we're going to be at 3 again. Forgot my degree symbol. So that's my table. -30 and 3, 60 and 4, 150 and 3. And if I flip all the way back to 5.2, I'm at 60 and 4. I'm at 150 and 3. I'm at 240 and 2. And I'm at 330 and 3. So it does the exact same thing, whether you use a table of values or whether you use the pattern. I'm more apt to use the pattern just because I don't have to rely on memorizing that table. There's just a few key points that I need to memorize. I'm missing my degree symbol on all these, which is bad, oh bad. Okay. So the something happening point is nowhere in your notes. I don't know how I came up with it, but it makes it way easier. Take your period, divide it by 4. Every 90 degrees, you'll have something happening. Now, as your period changes, so will your something happening point. You guys good if I flip? All right. Oh, geez. Now it's all a mess. Now we're adding all kinds of things. Good news is we don't have a shift in our period. Or a compression or stretch in our period. Okay. So, I have an amplitude. I have an amplitude of 2. I have a reflection in the x-axis. I'm going to tell you guys we don't do a lot of reflections in the y-axis for these. We keep it to one set of reflections. Just makes it a little bit easier for you. We have a horizontal shift of pi to the left. Ooh, sorry, you guys can't see that. Pi to the left. And we have a vertical shift one unit down. Okay. So where do coast graphs normally start? Maximum. So they usually start, coast graphs start at a max, which is at 0 and 1. That point is going to be transformed. That point is going to be transformed. If we are reflecting, if it was at a max, what point are we starting at now? If it was a maximum, if we reflect it, it's going to be at a minimum. So this reflection tells me to start at a min. So that's what that is telling me to do. If this were a sine graph, you'd still start at the median, but your next point would be to a minimum. Very confusing. We'll get better at it, I promise. Okay, I'm going to grab a different erasable pen because my other one was not great. And I'm going to have -1, -2, -3, -4, 1, 2, 3, 4. Okay. So I'm going to draw on my boundary lines with an erasable pen. This tells me also a pen that's not working. This tells me this is my new median. Because my old median was at 0. So if my old median was at 0, my new median is at -1. And again, if you're going to use these, you do not have to. If you're going to use those, they have to be dashed lines because they don't really exist. So what's my amplitude? 2. So I'm going 2 units up from here. So 1 unit is 0, 2 units is 1. I'm going down, so that's going to be at -3. Those are just my boundaries. They're just like, hey, Kelly, don't graph above or below these. My graph should all be contained within these. All right. Where is my first point? If it was at 0, where's my first point now? If we're shifting pi to the left. So now my first point is going to be at -pi and -pi. Ooh, forgot my negative sign. Remember that is telling us it starts at a min. The reflection tells me it starts at a min. So normally I started at max. The reflection is telling me I'm starting at a min. So I'm shifting -pi to the left. And I'm going to start at a minimum, which is going to be at -3. So not a lot of math, but lots to remember. And I find that that's like the downfall of chapter 3 and chapter 4 and chapter 5 is, but again, you can always go back to your table of values and apply your transformations like we did in chapter 1. Like the table of values will never lead you wrong. So if you're struggling with this quick method that I'm using, go back to your table of values and then do the math on that to get your new table of values. Okay, now I need my something happening point. Oh no, I need my period first. What's my period for this graph? It's going to be 2 pi divided by b. What's b? Is there a number outside the bracket? No, so it's a 1. So my period's 2 pi. And I encourage you to keep doing that until you feel comfortable finding your period. So my something happening point, I'm going to take my period and I'm going to divide it by 4. Because there are 4 sections to the graph, so that's why I'm dividing by 4. So that's going to be pi over 2 or 90 degrees. It's the same thing that we did before. This is only a helper. This is just a helper. It just helps me figure out what the heck I'm supposed to be doing. All right, so if I make this -pi over here, then every increment is a half. No, maybe I'll do this as a pi over 2 because I think my graph will be squishy if I don't do that. My graph is going to be super squishy if I did that. I can keep going if I want. Each increment was a half pi, so that would be 4 pi over 2, so this would be 5 pi over 2. And sometimes I find that doing everything as common fractions makes a lot more sense just when I'm going through the increments, so I don't have to think about it in my head. And then this would be 3 pi. That would be 7 pi over 2. You get the pattern. If you can understand patterns in math, you're doing really good. Okay, so my first starting point is going to be at -pi. Oh, I'm off the graph. -pi and -3. I'm off the graph. I don't have it. Well, that was a terrible decision on my part. Okay, so that's somewhere over here. I'm just going to draw that dot right there. Can't see it. It's off the graph, like it's over there. So if that is at -pi and -3, I'm going to go 90 degrees. Every 90 degrees, something's happening. So if I'm at negative pi, and I add 90 pi over 2 to it, where am I? If I'm at negative 180 and I add 90 to it, where am I? You're at negative 90, right? So at negative 90, you were at a minimum. Where are you now? Median. So you're going to go another 90 degrees. So you're going to go a half pi. And so you're at 0 this time, and you're at a maximum. And then you're going to go another half pi. You're back to a median. Another half pi. You're at a minimum. Another half pi. You're at a median again. And at another half pi, you're at a maximum. Now you can keep following this for as long as you'd like if it makes you happy. So now I'm just going to connect the points. Now I didn't even have my original starting point on it, but this is the graph. And again, your arrows have to be pointed in the same direction. Okay? And that would make sense, like if, that's kind of out here, negative pi to positive pi would be 2 minimums, and that is a period in a cosine graph. There's 2 maximums here, so from 0 to 2 pi, and you're like, Sky, and that looks kind of like a cosine graph already. But it had that shift in it. So a lot of stuff will look like a lot of stuff, and you'll think, oh, that can't be right. But as you can see, we're at 0, we're at a maximum. But this graph should start at a minimum, which it does. It's just I didn't have that point on my graph. Yep. They have to be pointing in the direction that the graph is going. So in this case, I was headed to a minimum on this side, and on this side, I was still headed to a minimum. So if you had finished your graph like here, this arrow would be pointing up because it would be headed to a maximum. So it does have to point in the direction it's going. If you're at a maximum and you point your arrow up, that's outside of the range. So I don't know if these are helpful to you. They are definitely helpful to me, but they're kind of like training wheels. Okay, this one is a trick graph. This one is a trick graph. Why is it a trick? Well, it's a trick equation. What do we have to do first? Anybody remember? Yeah, you got to common factor out that 2. So, excuse me? So before you can even start, you need to common factor out that 2. If you want a b value, it has to be in 2 sets of brackets. If it's like this, that's the trick. You got to common factor out that 2 first. You ready? First one's pretty easy, but all I'm going to do is I'm going to take 2 pi over 3 and divide by 2. So that's going to be 2 pi over 3 multiplied by 1 over 2. So this is going to be y equals 3 sine bracket 2 bracket x minus pi over 3 bracket bracket plus 2. You can't move forward, or you can move forward, but you're going to get it partially incorrect. So do what you will with that piece of information. And really, common factoring is just dividing out that number. So if you can see it, just do it. You don't have to show me the math, but I find sometimes with fractions, it's easier to actually do it on a piece of paper. I say this with all the love and hope in my heart, is that you get math fatigue. Like even doing a test, like you've been looking at the same question or you've had to come back and do it. I would take the time and actually math it out, but that's just my helpful advice. Okay, I'm going to look at my y stuff first. Where's my median now? It's not at 0, it's at 2, and my amplitude is 3. So I know I have a maximum of 5 and a minimum of -1. How does that feel for everybody? So this tells you your median. So my max is going to be 2 plus 3. My median is 2, and my minimum is 2 minus 3. So if you're wondering how I get those numbers, so that's how I decide how my increments are going to go on my y-axis. So it's completely up to you how you want to do it. Some of you might not like this. I'm trying to make our graphs not super squishy. Do you guys want the boundaries on there? Or do you want to try it without the boundaries? You want the boundaries? Okay. If you're feeling bold enough to not have the boundaries, try it without. And I can stop and look here and say, hey, this space is approximately the same as this space, or count the increments in it, right? Like just so to make sure nothing's wonky. Again, if you're using the boundaries, you need to have those dashed lines there. So if this were a 1-mark question and it said, tell me what the median, max, and min is, you don't have to graph it. You can just look at the equation and do it. All right. Okay, I got to do some math. Jeez Louise. Okay, so the B value, which is here, let me grab a highlighter. This is my B value. It is not the period, it is a helper. It is a helper. So period is equal to 2 pi divided by B. So my period is pi. So I should see 3 medians within the distance of pi. And now I'm going to do my something happening point. So I'm going to take pi, and I'm going to divide it by 4. The 4 never changes. So I know that every quarter pi, something's going to happen. Again, this is just a helper. That's not anything terribly mathematical. It's just something I picked up on, and it helps me graph better. We know that sines, this one doesn't have a reflection. We know that sines start at a median normally, so it should be starting at 0, 0. So where does 0, 0 transform to on this one? Where are we shifting? We're shifting pi over 3 to the right, so it's going to be positive. And where's our median? 2. It's kind of similar to vertexes on your quadratic. Your vertex was the value in here and out here. And that's sort of the same thing with our starting points, right? Now, on a sine graph, that's where they start. On a cosine graph, you'd have to find what the maximum is to find the starting point. So it's all kind of related, or it follows similar stuff. Okay, guys, anybody see a problem? Everything else has been beautiful, but this might be a problem. My start point is at a pi over 3. My something happening point is a pi over 4. If doing it in degrees makes more sense to you, what's pi over 3? That's 60 degrees. Now, this question is in radians. This question is in radians, so everything has to be in radians, but if you need to think about it in your head, what's pi over 4? 45, right? You could do common denominators for these fractions. You could do denominators of 12. So my start point would be at 4 pi over 12, and my something happening point would be every 3 pi over 12. You could do it as common denominators if that makes it easier for you, and I think it will for increments. If you want to think about it degrees, but if I make every one of these ticks, a pi over 12, so that would be 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12. You're just counting, right? Like you're just counting. Easy peasy. How big is my period? My period is just pi. But I'm not starting at 0. Where am I starting? I'm starting at 4 pi over 12. So I need to get at least 14 pi over 12 in here. No, 16 pi over 12, sorry. So 9 pi over 12, 11 pi over 12, 10 pi over 12. Okay, a little bit of the pain in the butt to do that, to get common denominators, but I promise you it will make your life so much simpler when you're graphing. And I mean, you can reduce fractions, but I find sometimes it just makes way more sense to put them as common denominators. Okay, so my start point is at, you guys told me my start point was at pi over 3 and 2, and pi over 3 equivalent fraction is 4 pi over 12. So we have 4 pi over 12, which is here, and we are at 2. Yep. Pardon?
Can you zoom in on the increments?
Is that better? Okay. So we said we were going to start at 4 pi over 12 and 2, because that's my median. Cosine graph starts at medians. And we are going to travel 3 pi over 12 for every next point. So if we're at 4, 1, 2, 3, and where would we be? A max or a min? Where do sine graphs normally go? There's no reflections. They start at a median and they head to a max. So at 7 pi over 12, we're at a maximum. And then at 7 pi, I'm going to add 3 to that, so 8, 9, 10. I'm back to a median. And at another 3, 1, 2, 3, I'm back to, I'm not back, I'm at a minimum. And then 1, 2, 3, I'm at a median. Oops. It's not erasable. I can't get rid of that extra line. So that's probably one of the highest levels of complication. You have phase shifts, you've got weird increments, you had to common factor out of it. So all of those things are kind of, this is probably the most complicated level that you're going to get on a test or a quiz or anything like that. So if you felt comfortable with this, or you didn't feel terrible with this, then you're doing really, really well. So transformations, we're going to need those for 5.4, both parts of it. And there's only one assignment for 5.4. There's not 2 assignments. So you have 2 days to work on it, which is a nice break. That's a good thing with me being away. Get a little bit of a breather.